Hello everyone, welcome back to our video. In today's video, I'll be showing how to use ChemDraw to draw simple molecular structures like this one on the top, benzene, toluene and trisubstituted benzene. Also like complex structures like this for phosphorine and the amino acid structures, or even you can draw supramolecular structures. So to begin with, I'll clean all and then I'll start from the beginning. So let's start from drawing a very simple compound like benzene. So how to draw a benzene? So when you open a ChemDraw, you will get a right side, left side, a column like this where you can select different molecules, and in bottom we have benzene. I click here, and wherever I wanted to paste, I put benzene here. So this is a simple benzene. Now let me put something called as a substituted benzene, where you have phenol. Let's take phenol. I'm going to for phenol, whenever you wanted to connect a bond, you just have a blue square there, and then you do it, and then I have to write OH minus on the top. For this, use text option. Click here and go here. When there is a blue circle or a blue square, you click there, type OH. So this becomes phenol. Okay, now I'm going to draw a substituted benzenes like chlorophenol. Let's find. So I can have a parachlorophenol. I'm going to type OH here, and then I'm going to type Cl here. Now let us draw multiple chlorine substituted benzene, like let's say like trichlorobenzene. So what I'm going to do is like this. So this is a di substituted benzene. If I wanted to have two chlorine substitution here, I have to click here and type chlorine. And if the case is that the same molecule or the same functional group repeats here, I do not need to type it again. I'm just going to keep here and double tap. So now this will reproduce the one previously selected. For example, if I wanted to have an alcohol in this ortho position, what I'm going to do, I'm just going to select the text, come to alcohol, just click once and then come back here, double click. So now alcohol is generated here. Suppose if you do not know the chemical structure but you just know the name, and then for that what we can go is you go to structures, and there is an option called as convert name to structure. Let's say like I'm going to have here name to structure. I'm going to give, let's say like biphenyl n. So there was a mistake, it seems. So I'm typing bipyridine. So let's see. Yes. So this is how it came. So now this name appears to be ambiguous because there are 2, 3 bipyridines available. Let's delete this, and this is technically called as 2,2 dash bipyridine. So now we will convert the structure to name, and this is called as 2,2 dash bipyridine. Suppose I will give now a specific instruction to draw 4,4 dash 4,4 dash bipyridine. Let's see what it generates. It generates a beautiful thing. Suppose if you wanted to have a name and the below, you go here, select structure, come to convert structure to name. Yes. So similarly, it can produce a lot, and there are also few templates available. Like these are templates. When you go here, you have amino acid side chains, amino acids, and then aromatic rings, bicyclic rings. Let's choose one amino acid, and I am going to just hold the cursor there and then come here. So I have selected this amino acid. I'm going to just click. So there comes the amino acid. If you do not know what is the name of the amino acid, go to the select option. It just got selected, and go to structure, convert structure to name. So this will give you what is this amino acid is about. So similarly, this structure is not cleaned, which means like the bonds are not in the right angle. You see it seems to be a strained bond. So now also I'm going to select this, and something is called as cleanup structure. So again you go to structure, it is called as cleanup structure. When I'm going to cleanup structure, I'll just give cleanup structure again, select this and give cleanup structure. Yes, now it seems to be a little more pleasing and the bond angles are right. So the old molecule looks like this. You see this bond angle, the one on the left side and the one on the right side are not same. So when I gave cleanup structure twice, yes, the first time and the second time, it got perfectly oriented. I'm just going to rotate it to make it perfect. So this is how you draw simple structures of the benzene ring or a toluene ring or aromatic aliphatic rings. For example, I can draw this is, so when I'm going to draw propane, so this is a propane, this is propane, and this becomes ethanol. Yes, so now what happened, suppose the bond angle cannot be same, I would have drawn ethanol like this. I'm going to select this and just select structure, cleanup structure, it becomes ethanol. So structure, convert structure to name, it gives me the right name. So select, pull up, yes. So this is a simple thing. And second thing what you can do is also you can draw a scheme where it involves a chemical reaction. These are the just chemical structures. So I'm going to delete this all and let's start drawing a scheme. A very simple reaction of nitration of benzene. So benzene is getting nitrated to form nitrobenzene. So in that case, what I'm going to do, I'm going to take this benzene and the benzene is going to react with nitric acid HNO3. So these are arrow symbols. There is a small arrow in here. I'm going to click it and there are multiple arrows available. I'm going to select which arrow I wanted. I usually select this arrow. Yes. And I'm going to do here. Yes, it seems really big. I'll select a small arrow now. Yes. Yes, this seems good. I'll select a text box. I'm going to type it on HNO3. You see, whenever I type O3, it comes to a subscript. So it is not like this 3. I mean, if I remove this, this comes like this. So this is not a good practice. So whenever this formula is active, it is going to come as a subscript. Even if it is not coming, select it and give it a formula, or you can also give it as a subscript. So I'm going to align it a little bit, come here, and then so benzene in the presence of reacts with nitric acid in the presence of sulfuric acid, H2SO4, H2SO4. So since the formula symbol is active, it was all super subscripts. So this forms a nitrobenzene. So either I can select, copy and paste, drag this over here, or I can use one more benzene template, bring it here, yes. And it is going to be a nitrobenzene. I'm going to select a bond and type NO2, NO2. Just select it, clean up the structure, Control Shift K. Yes, if you wanted to change the orientation, you can do it like this. It is up to you, or you can keep it like this. So I keep it like this. Okay, just a little to make it straight. Yes, perfect. So now we have drawn a reaction where you have benzene converting into nitrobenzene. Suppose you feel like the font is not good, double tap on this and then select A, and you can change whatever font you like it at different fonts, and you can also have the font size to be changed. So whatever, it can be done here. So this is way you have to draw a scheme. Suppose if I wanted to know what is the molecular weight of this molecule, how can I do it? I select the molecule, do a right click. Remember, select the molecule, do the right click, and come down to analysis. And in the analysis, there is something is called as name. What is the name? What is the chemical formula? What is the exact mass, molecular weight? M by Z means mass by weight ratio, which is measured during the mass spectrometry analysis or elemental analysis. I just want to know what is the exact mass. I just click here. It gives you below the exact mass. Suppose in for this molecule, I just do not want to just know the mass, but I wanted to know all the information. In that case, come down, give all. Now it gives you the full history of this molecule. The name of the molecule is nitrobenzene. The chemical formula is this, exact mass, molecular weight, and this is M by Z. So the abundancy of the M by Z is 123 is 100%, and there will be additional peak which is MZ plus 1, which is the protonated benzene nitrobenzene molecule, which will have the molecular formula of molecular weight of 124.04. And when you do elemental analysis, this is the predicted elemental analysis. The carbon will have 58 percentage, hydrogen will be 4, nitrogen is 11, and oxygen is 25.99, which is technically 26. So these are the informations which we can collect it. And moreover, if you wanted to know what is the expected NMR spectra of this, still you can select this, go to structures, come down, and here you see predict proton NMR. Shift, click here. There is a window popping up, and here you see the NMR is predicted. Well, for example, let's see here, and when I click here, since this molecule benzene loses its symmetry when you have a substitution, so therefore both the ortho position are similar, so it comes as a doublet, and the both meta positions are similar, so it comes here, and the para is comes around here. So when you zoom in, you can see the splitting of this molecule. So this is a doublet, this is a triplet, and this is a multiplet. So yes. So and the values are given here. The CH stretching frequency at the ortho position, at the ortho position is given at first, and the meta position is given as second, and the para position is given at below. So from that only you can know it is the splitting of the molecule. So the splitting is also given here, and what is the peak ratios around. So what is the atomic index, coupling parameters, constant and vector. So what are the hydrogens and carbons responsible for the splitting? Information is also given here. Suppose you have you are predicting that there is a mixture of product. So let's go back to this window, and I'm going to select the second. Yes, the first one was our first window where we were trying to draw benzene, and this is the second window. Let's say that I'm going to get a di-substituted benzene molecule instead of instead of one nitro. There can be like two nitro substitutions. One is here and one is here. I'm going to put the substitution. So now you have here. So these are two molecules which can be a side reaction. So I'm going to put a plus symbol. So when there is a excess of nitration, when the nitration is not controlled, sometimes you could get. So this software helps you to predict both the compounds together. If you have this mixture of compound in the NMR, what would be the NMR spectra? So now I'm just going to select only these two molecules. Again, go to structure, give. You can also predict the C13 as well as proton NMR. So now this predicts for both the molecules. So now this predicts for both the molecules. Now you see this is only for this proton, which is in between the both nitro substitutions, and it completely predicts. So whenever I click one of these spectras, it shows which molecule is that, and it shows which is the position in which it has been, the shifting has happened. So this feature helps you to analyze the NMR spectra of the complicated structure as well as the mixture of the when you have a mixture of structures to analyze. I'm just going to not save it, come back here. And second thing you can also do is to draw the mechanism of the reaction. For example, let's say like this is the reaction. Nitration of benzene is the reaction. So let's start with the mechanism. So the mechanism is first the the first nitric acid is changes into nitro molecule with the help of sulfuric acid. So let's say that first we have the nitric acid HNO3. That is the first step, HNO3. So now I have to draw the structure of HNO3 where I'm going to make a bond. So this will be the OH bond and there is an NO2 molecule attached to the oxygen. So this would be the oxygen and here you have NO2 molecule and here will be the H. So what does this sulfuric acid does is it helps in the dehydration of nitric acid. So now this is the actual structure of nitric acid which we are going to talk about, and this is a reversible reaction, so I'm going to put this symbol. Yes. And now what happens is in the presence of sulfuric acid H2SO4, this NO2, the molecule, yes, in the presence of nitric acid, I'm going to copy this. Control C and Control V is used for copying. So in the presence of nitric acid, what happens is there adds a hydrogen to this. So it abstracts the proton from the H2SO4. So this molecule now becomes higher protonated molecule. So this becomes H. So now you see there is a red square on the oxygen, which means it is not balanced. So therefore I'm going to give a charge to this oxygen molecule. This is positively charged. Yes, now it is balanced. So now to balance this positivity charge, what happens is I just wanted to extend this bond so that we know how the bond movement happens. Yes. And I'm going to give a different color to the hydrogen. Let's give it yes. So this is the protonated hydrogen, and this the let's see, yes. So there is a bond shifting here. So so since it is positively charged, the since it is positively charged, it has to be the electrons are fed into the bond towards the oxygen so that it is neutral and it becomes a neutral charge. So therefore now the end product would be going to copy this, just this, Control C, Control V, and come here, and after it has given, it would become, so now this bond is interrupted. Yes, sorry, just this bond is interrupted, and here, yes. So this is what it would become. It would become, since it has given a molecule, it has given an electron, this would become a positively charged molecule, NO2. So now, and this is the water. So because I'm going to clean up the structure, yes. So because of the sulfuric acid addition, there happens a dehydration, and we happen to generate a positively charged nitro group, and this nitro group adds to the benzene ring. So now benzene ring plus this nitro group, and this is going to this is going to attack on one center of the benzene ring. So this would be a non-reversible reaction where the benzene gets attached to a nitro group, and then it also gives out a hydrogen. So what happens, there would be a hydrogen here which would already be there. I'm going to make this hydrogen a different color, let's say like blue color. Yes, and this hydrogen would be removed as H plus. So now it would be NO2, and then we would be having a proton excess. So this proton will be again abstracted from the will be abstracted by the sulfuric acid. Thus the proton given out is proton taken. So the only change happens is the nitric acid is destroyed and then nitro is added and the proton is taken back by the sulfuric acid. And this cycle continues. So you can also explain how the mechanism is going on with the help of ChemDraw. And I use these tools to draw a structure. You can also draw different cyclic structures like this, or you can draw the aliphatic cyclic rings, all these. Also, you can use this template to draw conformations, different cyclopropyne rings, DNA templates, carbon nanotubes, as well as phenyl rings, polypeptides, stereo supramolecules, etc. For example, I can draw this supramolecule. Let's say this. All these supramolecules. So you can also, instead of trying to draw this complicated structure, it can also predict the structures and draw it. For example, I'm going to select this name. Since it is complicated, it feels difficult to select. So my point is like this software helps you to predict NMR. It helps you to predict the mass of the substance. It helps you to draw the structures very unambiguously. It helps you to explain the mechanisms. So I think like everybody has access to ChemDraw, and if someone do not have any access and you feel like it is not, you can directly go to the PerkinElmer software site, where PerkinElmer is the official partner, or they are the one who provides the software for ChemDraw. And ChemDraw is a very old software. It has got a lot of features, and the latest version of ChemDraw has multiple features in it. So you can go purchase it. Also, like there are a lot, please do not download crack from unauthorized sites because it also contains virus. Please make sure that you do not download it from an unauthorized site, which means you can cause it as a, you can lose data or your computer get corrupted. In some case somebody feels difficulty or a trouble to install ChemDraw, please leave a comment in the comment box and we will help you to solve it for free of charge. And we don't charge it, it is like a help. When I say it is a help, it is perfectly a help. So I wish you could use the ChemDraw and produce beautiful images and structures. Thank you.